students, I am Dr. B.K. Singh, Professor of Civil Engineering at Ajay Kumar Garg Engineering College, Ghaziabad. So, today we will discuss principle of mix proportioning with reference to design mix. So, previous lecture we have discussed how can you design a nominal mix, and today we will discuss the principle of design principle for design mix. So, we have, if you see the group of concrete, we have grouped the concrete in three categories. One is ordinary concrete, a standard concrete and high strength concrete. So, ordinary concrete is M10 to M20 grade, a standard concrete is M25 to M60, and high strength concrete is M65 to M100. So, this is the specification of IS, this is the specification of IS 456 2000 amended in 2013. This is the amendment. Okay. So, for design you can do for all the category. We are starting from ordinary concrete to high strength concrete. For economy we can go for the design mix. So, nominal mix design is for a small work, and suppose you have an unimportant work. If the work is more and it is important work, then for economy and better durability and strength, better standard, standard deviation will be less in the case of design mix. So, we have to go for the design mix, and design mix can be done for all that grade of concrete. So, this is the one of the important criteria for designing the concrete, environmental exposure conditions. So, we have 5 exposure conditions. One is mild exposure condition, moderate exposure condition, severe exposure condition, very severe condition, and extreme condition. So, definition of this has been taken from IS 456 2000. So, here mild means concrete surfaces protected against weather or aggressive conditions except those situated in coastal area. Similarly, if you consider the severe condition, concrete surfaces exposed to severe rain, alternate wetting and drying, or occasional freezing while wet or severe conditions. So, these are very important for your durability aspect. So, if it is a very severe, so or extreme. So, based on that, IS code has given certain restriction. So, mixed design consider all these parameter, so that your concrete should perform better in service condition. Then is the target strength for mix proportioning. Target strength for mix proportioning, because concrete is made of different type of ingredients with different properties and lots of variation is there. So, you cannot get the strength whatever you are desired. So, you have to keep certain margin for that. So, there is a variation in the strength. Suppose you are testing many cubes. So, there will be a standard deviation, some variation will be there. So, they have given two formula for that. This is the mean target strength. FCK is a characteristic strength, which is a compressive characteristic strength at the age of 28 days. S is a standard deviation, and X factor based on grade of concrete. So, this thing has been given in IS 10262 2000 2019. So, this is the latest revised code that you have to follow. Previous code in 2009, this equation was not there. So, the standard deviation is very important while we are considering the mixed design. So, what will happen, suppose you want to make a concrete So, like this. Okay. If you are getting a very good bell shaped curve, if you are getting a very good bell shaped curve, sorry, or you may get a flattened curve like this, sorry, flattened curve like this. So, in this case this is having very poor. So, standard deviation will be higher. In this case standard deviation will be higher. Okay. And if your quality control is good, but then we can get bell shaped curve. Okay. So, IS code has given, if you do not have proper data, so in that case a standard deviation in first trial you can assume certain value, and similarly for x. So, based on the grade, if you see here x factor has been given in this code, M2 into M15 you can take 5, M20 to M25 you take minimum 5.5, M30 to M60 you can take 6.5, M65 and above means for high strength concrete you have to take 8. So, what it mean? Mean target strength minimum is FCK dash is nothing but FCK plus x. So, say I want to produce M50 grade concrete, say I want to produce M50 grade concrete. So, first trial, so during the mixing designing, so first trial you have to adopt this x equal to 6.5. So, what is that value? So, mean target strength value will become 50 plus 6.5. So, this value must be minimum should be designed for 56.5 Newton per mm square. So, that is the meaning of this equation. Similarly, suppose we are considering the standard deviation. So, standard deviation value is here 3.5, 4, 5, 6. So, depends on the grade of concrete. So, suppose our grade of concrete is M10 to M15, then standard deviation you can take 3.5, M20 to M25 4. So, M30 to M60 5, and M65 onwards you can take 6. So, this is for good quality control at site. If you do not have better quality control at site or as well as a mixing plant, then we have to increase this value by 1 Newton per mm square standard deviation. So, this value, suppose you want to calculate the mean target strength FCK dash. So, this is given by FCK plus K into S. So, K is what? K is a statistical constant. So, that is for 95% confidence limit. So, if your limit is 95% means maximum cube should pass, at least 95% cube should get at least the designated value say 50. So, you should get 50 plus value, 50 or 50 plus 95%. So, even 5% sample may fail. So, acceptance criteria is different. So, that you have to understand. So, that we will discuss later what is the acceptance criteria, but whenever you go for the mixed design we have to follow this value. So, suppose you do not have a standard deviation, we do not know about the contractor what is their quality. So, what we have to do, first trial we can take this, but as early as you are getting the field trial say for 30 at least for 30 samples. So, 30 sample, one sample consists of 3 cubes. So, totally if you are getting about 90 cubes, minimum 90 cubes, then we can get the actual value of standard deviation that you can put and revise your design. But for initial state you have to take from the this table. So, say I want to design M20 grade concrete. So, suppose I want to design M20 grade concrete. So, just you put 20, K is 1.65 for 95% confidence limit and into 6 into 5. So, that much value you have to take in a mixed design. So, that is the mean target strength you have to consider while you are designing the mix. Okay. So, this is only for design purpose. So, once you have designed, then we have to consider the compliance criteria. So, once we have got the value of water cement once we have got the mean target strength, then we have to decide what should be our water cement ratio to achieve that value. So, achieving that value we have got these 3 curve 1, curve 2 and curve 3. So, curve 1 is for if you are using a 33 grade cement, OPC 33 grade, and curve 2 is for 43 grade and this curve 3 is for 53 grade ordinary Portland cement. And if the cement contains Portland pozzolana cement or granulated ground blast furnace slag, then in that case you can use this curve also for PPC, Portland pozzolana cement, or the cement which consists of GGBF. So, that case you can use the curve number 2. So, we have suppose we have got the mean target strength here, say I am getting 45, let us say I am getting the mean target strength of 45. So, just you go for like this in this graph, okay. And here you can select the what should be our water cement ratio here. So, that is the importance of this graph. So, based on that you will be selecting what should be our water cement ratio. So, this graph is very important, and this water cement ratio means what is this water. So, water is nothing but that has to be considered free water cement ratio. So, free water cement means surface your aggregate will be saturated, but surface dry. Surface will be dry, but inside pores will be filled with water. So, that situation we have to consider while taking this value. So, nowadays we have a modern mix plant where they have a facility of automatically calculating how much your coarse or fine aggregate is saturated. So, based on that they calculate the amount of water and they adjust the amount of water required. Then we have to consider approximate air content, because whatever the means you adopt when you are concreting, either it is self compacting concrete or it is a compacted with vibrator with different means of different types of vibrator, we will always have some amount of entrapped air. So, depends on the maximum nominal size of aggregate, say it is a 10 mm. So, you can expect about 1.5% entrapped air. Similarly, it is a 20 mm and downside aggregate, then you can expect about 1% of entrapped air. And as the size of aggregate is increasing, amount of entrapped air going on reducing. So, 40 mm downside aggregate you get about 0.8. So, that also you have to consider while you are designing the mix. So, this table has been taken from IS 10262-2019. So, this is a not a air entrained, this is a entrapped. So, air entrained means purposely we put in that. Okay. So, we put some amount of chemicals, so that some percentage of air will be created, bubbles voids will be created throughout mass of the concrete. So, that is apart from that, this is the entrapped air, naturally it will be entrapped. So, another case is here, if you see the IS 452,000. So, for durability requirement, this table must be considered. So, in this table what we are observing here, we have a 5 exposure condition. One is mild exposure condition, moderate exposure condition, severe, very severe and extreme. So, based on that we have two criteria, plain concrete and reinforced concrete. For plain concrete also they have given the minimum amount of cement must be there per meter cube of the concrete. So, say I have a mild exposure condition and we are using a plain concrete. So, minimum 220 kg of cement is required and maximum free water cement ratio is 0.6. You cannot go more than 0.60, even it is this one. And minimum grade of concrete they have not specified here, but if it is a moderate condition, then minimum cement content they have specified 240 and water cement ratio, maximum water cement is 0.6, and you cannot use the concrete less than M15 grade concrete there. So, similarly, let us say we have last extreme condition and we want to produce some concrete for plain cement concrete. So, minimum 280 kg of cement is required per meter cube and water cement ratio is restricted to 0.4, and you cannot use grade of concrete less than M25. So, sometimes what will happen, people may think that 0.40 is even you are restricting the 0.40 and 280, even you may get the grade of more grade of concrete. Let us say you are obtaining by testing M30 grade. So, does not matter, their strength is not important, this has to be restricted. So, this 0.40 maximum free water cement ratio and minimum cement content 280 is important, that you must adhere with, and for strength criteria you have to consider this M25 grade. Similarly, you consider the reinforced concrete. Similarly, we consider the reinforced concrete. For reinforced concrete, once again there is a restrictions here. So, minimum cement content should not be less than 300 kg per meter cube in concrete, and for RCC work minimum grade of concrete used is M20. So, this is the minimum grade of concrete for RCC, and this is also for very moderate condition, very mild exposure condition. So, most of the time we will not get a mild exposure condition. So, we cannot use M20. So, most of the time you have to adhere with M25 and greater. So, here there is a restriction of water to cement ratio 0.55. So, this is important, even without putting the 300 kg of cement, by controlling the water cement ratio by putting some admixture, you can be able to achieve M20 grade concrete, but you have to check that minimum amount of cement should also be specified when we are receiving the mixed design from the concrete making plant. Okay. So, that is very important, that this cement must check cement plus strength criteria, whether it is going to comply the acceptance criteria of M20 or not. Similarly, we have let us say we discuss the extreme condition. So, their restriction is you should not use less than 360 kg of material, cementitious material here, and here restriction of maximum free water cement ratio is 0.40 and minimum grade of concrete you have to 40. So, this is very important, that we cannot go bypass this table when we are designing the mix concrete. Okay. So, one criteria you are getting from the design, another from the environmental exposure condition. Okay. So, here there is a restriction of water content per cubic meter of concrete for nominal maximum size of aggregate. If our maximum size of aggregate is 10 mm, and then we have to use the maximum water content 208. Similarly, for this is a nominal maximum size of aggregate is 20, then minimum is 186, and if it is a maximum size of aggregate is 40, then it is 165. So, this has been given for certain specified slump value, okay, certain slump value and types of aggregate, okay, types of aggregate. So, accordingly we have to change this value. If the slump value is increasing, this amount of water will increase. If you are using the admixture, then this amount of water, suppose you are using the water reducing compound. So, that case also this value may reduce. Okay. So, that thing also you must consider while doing the design. So, this because water content is very important. If proper water content will not be there, we will not be able to get the proper workability. So, two things is important. For workability purpose, we must put certain minimum amount of water, some amount of water is restricted, okay. And for strength criteria, we must have also certain restriction of water. If water will increase, what will happen? Their strength will go, because that depends on the water cement ratio. So, that graph you have seen here. Okay. So, now you come here. So, once you got the calculation, we have to go for the calculation of cementitious material content. So, the cement and supplementary cementitious material. So, what is the supplementary cementitious material? Apart from the cement, we can use fly ash, you can use granulated, grounded, blast furnace slag, you can use metakaolin, you can use rice husk ash, you can use calcined clay. So, like this you have to use these are the you can use silica fume. So, depends on the grade of concrete and a special requirement, we can use the supplementary cementitious material. So, this material you have to consider while you are calculating the free water cement ratio, because water cement ratio we have calculated water cement ratio, free water cement ratio based on the, I have seen this previous curve we see here. So, based on that we have selected certain water cement ratio here. So, based on that this is nothing but water cement, or you can say water cementitious ratio. So, from there we can calculate how much amount of water is required. So, we got the water cement ratio from here for some particular mean target strength. So, Fck for particular Fck value you got certain amount of water cement ratio. Okay. So, here if you got the water cement ratio, say let us say you are getting some value x value you are getting here. So, you can calculate what should be the total cementitious material, because you have calculated the amount of water. Water from here you have calculated the previous from the previous table, minimum amount of water here you can take from this criteria, So, as you have decided the minimum maximum water content, then we have got the value of this water cement ratio. So, based on that we have calculated the amount of cement required, how much minimum cement means cementitious material. So, after that, as you have got the cementitious material, then we have to go for proportionating the coarse aggregate and fine aggregate. Okay. So, volume of coarse aggregate per unit volume of total aggregate for different zones of fine aggregate for water cement statious material ratio of 0.5 is given in IS 102622019. Okay. So, here is the nominal maximum size of aggregate, this is 10 mm, 20 mm, 40 mm, and here in this table this is a zone sand. We have a 4 zone, zone 1, zone 2, zone 3, zone 4. So, that we are getting from sieve analysis. So, from sieve analysis we are getting the 4 zones. So, depends on the zones how much should be the volume of coarse aggregate. So, suppose our sand is from zone 2. So, in that case you can see if our aggregate size is 10 mm and down, then we have to take the 50.5, 50% will be coarse aggregate and 50% will be fine aggregate. If we are using 20 mm size, 20 mm and down size aggregate, so in that case what you are observing? So, our sand content will be 42% and coarse aggregate will be 62% for zone 2 sand. And if your size of maximum size of aggregate is 40 mm, that time what you are getting? It is a 0.71, means about 70% part will be coarse aggregate and about 30% part will be fine aggregate. So, what we are observing? As the nominal maximum size of aggregate is decreasing, amount of sand is increasing because more voids will be there. Similarly, suppose you have a more size of the aggregate, if the size of the aggregate is more, so what we are observing? Our amount of sand decreases. So, all these things we have to consider while we are designing for the mix. So, once we have obtained the volume of fine aggregate, volume of coarse aggregate, weight of cement, weight of water, weight of admixtures. So, then we have to go for proportioning, proper proportioning. For proportioning we need the specific gravity of all the material. So, what is the specific gravity of material we need? We know the specific gravity of cement, we know the specific gravity of water, specific gravity of admixture, fly ash, cement. So, based on that we can do the necessary calculations and calculate the proportions. So, once you this is the for first trial. So, then what we have to do? Second trial, you reduce the water by some amount and do the trial mix, get the strength, and similarly you increase the water and for 3 trials you get the what should be the best value for your mix design. Based on the judgment you can give the proportion. Okay. So, this was the requirement of the principles of the mix design. Okay. Thank you.